Welcome, my friends. You are now entering the quiet world of mathematics, a place where numbers whisper and theorems stretch like hammocks under the stars. And yes, I know that sounds poetic, but bear with me. Tonight or today, depending on when you press play, we are not solving equations, we are solving mysteries. The mysteries of people who built modern math and then, somehow, were forgotten by history. Now, math usually comes with the reputation of being cold, rigid, and full of symbols that look like they escaped from an alien keyboard. But at the heart of it, math is a very human story. Behind every formula, there is someone who sweated over it, obsessed over it, maybe even argued about it at dinner parties until all their friends left the room. And the funny thing is, we tend to remember a very small club of men with long beards and even longer egos, names like Newton, Euler, Pythagoras. You know, the guys who got all the credit and probably never washed their wigs. But hidden behind them, like the quiet students who always had the right answer but never raised their hands, are the women. Brilliant women. Women who shaped math, transformed it, and sometimes saved it. And yet history either ignored them or wrote them out completely. This is not a small detail. This is one of the biggest secrets of mathematics. Because if you take away these women, if you erase their theorems, their translations, their discoveries, you would not recognize modern science. Physics would crumble, computers would not exist, and NASA probably would have had to cancel the moon landing. Imagine Neil Armstrong standing there trying to jump to the moon with a really big ladder. So tonight, I want to take you on a journey through that secret history. We'll meet philosophers in ancient Alexandria, rebels during the Renaissance, geniuses who hid behind fake male names, and codebreakers who literally helped win wars. It is a story of tragedy, of triumph, and occasionally of hilarious academic drama. Because believe me, mathematicians fight harder than gladiators when it comes to taking credit for things. But before we dive into the lives of these forgotten women, we have to ask a question. Why were they forgotten in the first place? Why did their names vanish from textbooks while the bearded men lived forever on chalkboards? The short answer is society. For most of human history, women were simply not supposed to do math. They were supposed to sew, cook, or, if they were lucky, play the piano and smile politely. Doing algebra was not on the official list. In fact, in some places, letting a woman study mathematics was considered about as dangerous as letting a toddler play with fireworks. People honestly believed it would damage their brains, or even worse, make them too clever. And clever women, as history shows, scared the life out of men in power. And so, time after time, when a woman actually managed to do brilliant math, history politely coughed, turned the page, and pretended it never happened. Or even better, gave the credit to a nearby man. It's like a magician's trick, but instead of pulling a rabbit out of a hat, they made women disappear. Now, we could spend hours analysing all the social theories and gender politics behind this, but since this is a bedtime story about math, let me put it simply. History is written by the victors, and in this case the victors were a bunch of grumpy old men with beards, and possibly questionable hygiene. And when those men wrote down the story of math, they forgot to include the women who had been there all along, quietly moving the world forward with pen, paper, and a lot of stubborn brilliance. But here is the fun twist. The math itself never forgot. Equations don't care about your gender. A theorem is true whether it's proven by a man in a powdered wig or a woman working by candlelight while everyone tells her she shouldn't. Numbers are equal opportunity employers, and so, even when the people were erased, the ideas survived. That is why we can rediscover them now and tell the stories that should have been told all along. So, in this video, or should I say this 2-hour-long lullaby of genius, we will walk through history, from the marble halls of Alexandria, to smoky salons in Paris, to the war rooms of World War II. You'll meet names you might know, like Ada Lovelace, the so-called first computer programmer, but also names you probably have never heard in your life, like Sophie Germain, who tricked Napoleon, or Emmy Noether, who impressed Einstein himself. And we'll laugh along the way, because as serious as mathematics is, mathematicians are some of the funniest and strangest characters in history, and if you stay awake long enough, you might even learn a thing or two. But let's be honest, you probably won't, because the whole idea of this channel is that my soothing monotone voice, combined with long stories about 2,000 years of forgotten math geniuses, will eventually knock you out cold. And if that happens, if you drift off halfway through Hypatia's tragic story, I won't take it personally. In fact, I'll take it as a compliment. You fell asleep in math class, but in the most productive way possible. Still, before you doze off, I want you to carry one idea with you. Math is not just about numbers, it's about people. People with messy, funny, heartbreaking, inspiring stories. And some of the best stories belong to those who were left out of the spotlight. The women who secretly built the foundations we now stand on. So settle in, wrap yourself in a blanket, grab a cup of tea, and prepare to step into a time machine. A time machine powered not by gears and steam, but by equations, symbols, and the occasional sarcastic comment about how unfair history can be. We'll start as many good stories do, in the ancient world, in Alexandria, a city of books, of scholars, and one very brilliant woman named Hypatia. She was the first lady of mathematics, and she paid the highest price for it. But before we get to her, let's take one last breath here at the beginning. The quiet place where we remember that math is not cold, not boring, not lifeless. It is a story of humans, some remembered, some forgotten, and tonight we are bringing them back to life. So let's face the big question. Why were women forgotten in mathematics? Why do we have textbooks filled with bearded men posing dramatically next to triangles, but almost no women, even though half of humanity has always been women? The short answer is society. The long answer is also society, but with more footnotes and a lot more beard hair. For most of history, women were told that their job was to run the household, raise children, and if they had extra time, maybe embroider a nice pillow. But definitely not solve equations or invent new branches of geometry. That was considered man territory, guarded by universities, academies, and the occasional cranky philosopher. Now here's the funny part. Whenever a woman actually tried to do math, people didn't just shrug and say, well, that's unusual. No, they panicked. They wrote essays about the dangers of women learning too much. Doctors even published warnings that too much study would ruin a woman's health. They seriously thought that learning Latin or calculus might overheat the female brain. One doctor wrote that if a woman spent too much energy thinking, her womb would dry up like a raisin. Imagine going to a medical checkup and the doctor saying, sorry ma'am, you did too many fractions, your uterus is gone. And so, in many times and places, women were actively barred from schools, from universities, from academic societies. If they wanted to learn, they had to sneak around, find private tutors, or later on pretend to be men in order to submit their work. You would think this was the plot of a Shakespeare comedy, but no, this was real academic life. History also had what I like to call the credit problem. If a woman did manage to contribute something huge, chances are the credit went to a man standing nearby. Husband, teacher, colleague, it didn't matter. The history books would smile politely and write down his name. This is why we have 1,000 equations with male names and very few with female ones. Women weren't invisible, they were erased. Now before we get too gloomy, let's sprinkle in a little humour, because honestly, some of the excuses men gave were ridiculous. In the 1800s, one critic claimed that if women studied math, their heads would literally shrink. He didn't mean metaphorically, he meant their skulls would get smaller because the female body couldn't handle mental strain. Imagine being in math class, opening your textbook, and your head just shrinking 2 sizes. Sounds more like a cartoon than a medical diagnosis. And yet, despite all these barriers, women kept sneaking into the story. Some were daughters of professors who secretly taught them. Some were nuns with access to monastery libraries. Some just flat out refused to listen to anyone telling them no. And here's where the real injustice begins. These women weren't just dabbling in math for fun. They were brilliant. They made discoveries that changed science forever. And still, many were either ignored or remembered only as footnotes in the stories of famous men. Why? Partly because of bias, but also because of the way history is written. Think about it. When we tell the story of math, we love the idea of the lone genius. The solitary man scribbling equations in a candlelit attic, changing the world with pure thought. It's dramatic, it's romantic, it's also complete nonsense. Math has always been collaborative. It's a giant relay race of ideas, passed down across cultures and centuries. But when historians told the story, they picked out the men as heroes and left everyone else in the shadows, especially women. And here's the kicker. Even the men who admired these women sometimes helped erase them. Take Einstein. He said Emmy Noether was a genius, greater than himself in pure math. But how many people today know her name compared to his? Exactly. It's not that Einstein lied, it's that the world listened selectively. So what we're left with is a kind of math history that looks like Swiss cheese full of holes, entire lives and contributions missing, and those holes are mostly shaped like women. Now I want to pause here and say something important. When we retell these stories today, we don't do it just to feel guilty about the past. We do it because history is more interesting and more truthful when it includes everyone. Think about how much richer the story of music is when you add forgotten composers, or how much better the story of space travel became when people learned about the women at NASA. It's the same with math. The story doesn't just get fairer, it gets better. And also, let's be honest, it gets funnier. Because mathematicians, male or female, have always been quirky. Some wore strange clothes, some refused to eat anything round because they thought circles were sacred, and some wrote letters to kings pretending to be men just so they could sneak their equations into the Royal Academy. These are not boring people. These are rebels, dreamers, and occasionally absolute lunatics. And when you add the forgotten women back in, the story is packed with even more drama, tragedy, and comedy. So, to circle back, why were women forgotten in math? Because the gatekeepers of history didn't think they belonged. Because society wanted to protect its traditions more than its truth. And because, frankly, people in power often fear new voices, especially when those voices are smarter than they are. But here's the twist. Math itself doesn't care about any of that. Math is not loyal to prejudice. 2 + 2 = 4 no matter who writes it down. Emmy Noether's theorem about symmetries works whether her name is remembered or not. Hypatia's lectures on conic sections matter whether or not her city ever built a statue of her. Numbers are stubborn. They don't care who you are. They survive. Which means that in telling these stories now, we're not adding something fake. We're uncovering what was already there, just hidden under centuries of dust, bias, and very bad beards. So as we move into the next chapter, think of this as an excavation. We're brushing away the sand of history to reveal the real builders of math. Not just the famous men in portraits, but also the women in the margins. They were there, they were brilliant, and now finally they get their place in the story. Our first stop will be ancient Alexandria, a city where scrolls piled higher than buildings, philosophers argued in the streets, and one extraordinary woman stood at the center of it all. Her name was Hypatia, and her story is as inspiring as it is tragic. Let's travel back in time, way back to the city of Alexandria, around the year 400. Imagine marble streets, tall columns, markets full of spices and scrolls, and if you're unlucky, the occasional camel sneezing in your direction. Alexandria was one of the intellectual centers of the ancient world. It had the famous Library of Alexandria, the dream of every scholar, and probably the nightmare of every librarian because, let's be honest, organizing 500,000 scrolls without Google search must have been a full-time job. And right in the middle of this buzzing city lived a woman named Hypatia. She was a mathematician, a philosopher, and a teacher. Some even call her the very first woman in recorded history who was openly recognized as a mathematician, which, considering how women were treated back then, is a miracle in itself. Hypatia was the daughter of Theon, a scholar who worked at the Library of Alexandria, and Theon, bless his soul, decided not to waste time teaching her embroidery or how to pour wine gracefully. No, he taught her mathematics, astronomy, and philosophy. Basically, he raised her to be a genius. It's like if your dad skips bedtime stories and instead reads you Euclid's Elements. Once upon a time there was a right triangle, and it lived happily ever after. By her 20s, Hypatia was already a famous teacher. She taught mathematics and philosophy to the young elite of Alexandria, and not just to women in secret, but to men openly in public lectures. Students travelled from far away to hear her explain geometry, astronomy, and the works of Plato. She would walk through the city dressed in philosopher's robes, discussing ideas in the streets like a rock star of logic. If Twitter had existed back then, she would have been trending daily with hashtags like Team Hypatia and Mathis Life. But let's make this clear. She wasn't teaching boring arithmetic. She dealt with high-level ideas, conic sections, the motion of planets, the mysteries of numbers. Her students described her as calm, eloquent, and wise, and unlike some other philosophers of the time, she didn't rant angrily or shout. She had the kind of voice that soothed and inspired, which is ironic, because 2,000 years later, here I am also trying to soothe you to sleep with math. Hypatia's reputation grew so large that she became a symbol of knowledge itself. Even the city's political leaders would come to her for advice. She wasn't just a mathematician, she was a public intellectual. Imagine if your local mayor skipped the lawyers and went straight to your math teacher for help. That was Hypatia. But here's where her story turns tragic. Because while Alexandria was a place of learning, it was also a city of tension. Religious and political groups were constantly fighting for power. And Hypatia, being a prominent woman, a philosopher, and worst of all, a rational thinker, became a target. She represented the old pagan traditions of philosophy in a world that was rapidly shifting to new religious authority. And in times of conflict, people don't always appreciate calm, reasonable teachers. They want someone to blame. In 4015 AD, Hypatia was attacked by a mob. It's a horrifying story. They dragged her from her chariot, murdered her brutally, and burned her body. It was not just an act of violence, it was a symbolic attempt to destroy knowledge itself. The idea was, silence the philosopher and maybe the questions will go away. Spoiler alert, the questions did not go away. Now I know that sounds grim, and it is. But here's the twist. Hypatia's ideas survived. Her students carried her teachings forward. She influenced the course of mathematics, astronomy, and philosophy. Her name lived on as a legend of learning, even if most history books left out the details. In many ways, she became a symbol of the pursuit of knowledge against all odds. And let's pause here for a bit of humour, because this is heavy stuff. Imagine being one of her students trying to explain later on what happened. Yes, my teacher was Hypatia. She taught me conic sections, astronomy, and oh yeah, she was murdered by a mob. But otherwise, great semester. Not exactly the usual school report card. Still, Hypatia's life tells us something profound. She wasn't just teaching math. She was living proof that women could excel at the very highest levels of intellectual life. At a time when women weren't supposed to even sit in a classroom, she ran one. At a time when men claimed that women couldn't handle abstract thought, she was solving problems that made those men look like toddlers playing with building blocks. And this is the point where we see how unfair history can be. Because if Hypatia had been a man, her story would probably be on every page of every textbook. Kids would be memorizing her theorems in school. Instead, for centuries, she was remembered more as a tragic victim than as a brilliant thinker. But here's the thing. Hypatia was more than her death. She was more than the mob that tried to erase her. She was a mathematician who shaped the way people thought about numbers and the cosmos. She was a philosopher who believed that truth could be pursued through reason. And she was a teacher who lit the spark of curiosity in countless students. If you've ever had a teacher who made you see the world differently, who made a subject come alive, then you already know a little bit about what Hypatia meant to Alexandria. She was that teacher, 2,000 years ago, and the echoes of her voice are still here. So the next time you see a circle, a parabola, or the night sky filled with stars, remember that there was once a woman in Alexandria who stood before her students and said, "Look, think, question." And in that moment she was planting seeds of knowledge that would grow for centuries. To sum it up, Hypatia of Alexandria was the first lady of mathematics. She lived bravely, she taught brilliantly, and though she died tragically, her ideas lived on. She was forgotten by many, erased by some, but rediscovered by those who still believe that math belongs to everyone, not just to men with scrolls and beards. And now, with Hypatia's voice echoing through time, let's move on. Because she wasn't the only woman who shaped the early world of math. There were others, half legend, half reality, whose names flicker through the pages of history like stars. Let's meet them next. When people talk about women in ancient mathematics, Hypatia usually gets the spotlight. And fair enough, she deserves it. But she wasn't alone. The ancient world has whispers of other women who touched the stars of mathematics and astronomy. Some of them are real, some are half legend, and some are probably mythical. But all of them remind us that women were thinking about numbers long before history books wanted to admit it. Let's start with a name from ancient Greece, Diotima. Now, was she a mathematician? Not exactly. She was a philosopher mentioned by Plato in one of his dialogues. But here's the twist. Some scholars believe Diotima might have been real, a wise woman who taught ideas about logic, reason, and the nature of knowledge itself. And honestly, philosophy and math in those days were pretty much best friends. You couldn't talk about one without running into the other. So even though Diotima is remembered as a philosopher, it's not a stretch to imagine her contributing to the mathematical spirit of ancient Greece. And here's a fun thought. Imagine being a woman philosopher in Athens, surrounded by guys like Socrates, Plato, and Aristotle. You'd have to interrupt constantly just to get a word in. Yes, Socrates, very deep thought about virtue, but can we please get back to the geometry problem on the table? I'm guessing she had the patience of a saint. Then there's Aglaonike, sometimes called the first female astronomer of Greece. She was famous for supposedly predicting lunar eclipses. Now, her critics at the time said she wasn't really predicting them. They accused her of being a witch who magically made the moon disappear, which is hilarious because all she was doing was basic astronomy. It's like saying, oh, you know when the tide comes in? Must be witchcraft. Poor Aglaonike was probably sitting there with her calculations thinking, guys, it's literally the moon's shadow, calm down. Still, imagine the power of being the only person in your village who could say, tomorrow night the moon will vanish. People must have thought she had a direct line to the gods. In reality, she had a direct line to arithmetic and the cycles of the sky, which, if you ask me, is even more magical. Now, the ancient world also gave us legends. One is about a woman named Pandrosian, who supposedly taught geometry in Alexandria before Hypatia. We don't know much about her, but her name pops up in some ancient commentaries, just a little trace like footprints in the sand that got washed away. It makes you wonder how many other women's names were lost completely, how many scrolls in the Library of Alexandria told their stories, only to go up in smoke when the library burned. That fire didn't just destroy books, it erased lives. And then there's the even stranger category, the women who exist somewhere between myth and history, like Theano, said to be the wife or student of Pythagoras. Some accounts credit her with writing about mathematics, including the famous golden ratio. Did she really? Hard to say. The Pythagorean school was kind of like a math cult. They had secret rules, rituals, and a strict no beans policy. Yes, you heard that right. They thought beans were evil, so it's possible Theano really was a mathematician. But her story got buried under all the Pythagorean weirdness. If she did write about the golden ratio, that means one of the most beautiful numbers in math might have been introduced by a woman, not by her husband. That would be one of history's biggest credit swaps. And speaking of the golden ratio, let's have a little detour. This number about 1.618 shows up everywhere, in art, architecture, nature. Some people even claim your face is beautiful if it matches the golden ratio. Personally, I think beauty is more than math, but try telling that to Renaissance artists measuring noses with rulers. If Theano really wrote about this ratio, then she was way ahead of her time, exploring a number that still fascinates us today. It's also worth noting that in many ancient cultures outside Greece, women were involved in mathematics, but we barely hear about them. In Babylon, women worked as scribes, and scribes had to know math. In Egypt, women could inherit property, manage businesses, and sometimes study medicine, which required calculations. There must have been brilliant Egyptian women crunching numbers on papyrus, balancing accounts, maybe even designing pyramids, but their names are gone, lost to time. And that's the frustrating part. For every Hypatia whose name survived, there are probably dozens of women we'll never know about. Women who predicted eclipses, solved geometry problems, or wrote treatises that didn't survive. The ancient world wasn't short of intelligent women. It was short of people willing to write their stories down. But here's the silver lining. Even these faint traces remind us that women were always part of the story. From Diotima the philosopher, to Aglaonike the eclipse predictor, to Theano and her golden ratio, to nameless scribes and teachers, the story of ancient mathematics was never just male. It was just written that way. And I have to say, I kind of love the fact that Aglaonike was accused of witchcraft for predicting eclipses. It's such a perfect example of how people react to knowledge they don't understand. It reminds me of how, centuries later, women in science were accused of being unnatural, dangerous, or unfeminine. The pattern repeats. A woman uses her brain, society freaks out. But over and over the math proves them wrong. The moon doesn't vanish by witchcraft. It vanishes because of predictable cycles. And the genius who understood that was not a man in a toga, but a woman who studied the skies. So let's raise a glass or a papyrus scroll to these other women of antiquity. Their stories are fragments, but they matter. They show us that Hypatia was not an exception dropped out of nowhere. She was part of a hidden tradition of women who loved numbers, stars, and patterns. a tradition that history tried to bury, but which we can still glimpse if we squint hard enough through the dust of time. And as we leave the ancient world, we head into the Middle Ages, a time when Europe was mostly busy with plagues, castles, and very bad hygiene. But mathematics was alive in the Islamic world. And guess what? Women were there too, in monasteries, in schools, sometimes even advising rulers. So grab your medieval imagination, because next up we'll peek into monasteries, Golden Age Baghdad, and discover the forgotten female figures of the Middle Ages. When people think of the Middle Ages in Europe, the first images that usually pop up are knights in shining armour, castles, plagues, and maybe some monks writing books very, very slowly. What people usually don't picture is women studying mathematics. But the truth is, even in this period that we like to call the Dark Ages, women were still out there doing math, solving problems, and in some cases pushing the boundaries of what was possible. Now let's split the world in two for a moment. In Europe, after the fall of Rome, education was mostly in the hands of monasteries. Picture rows of monks hunched over manuscripts, drawing neat little numbers and copying text by candlelight. And yes, some nuns were part of this too. Nuns often ran convent schools for girls, and some of them had access to books on arithmetic, astronomy, and logic. It wasn't easy, but it was possible. Imagine a nun in the 1100s teaching geometry to her students, while outside people were literally fighting over chickens in the street. That's dedication. And here's the thing. Learning math in a monastery was probably not glamorous. No chalkboards, no calculators, just wax tablets and endless patience. But the very act of teaching and preserving knowledge was powerful. Every time a nun copied a text, she was keeping math alive for the future. And while most of their names didn't survive, a few did. One is Hildegard of Bingen. She's mostly remembered as a mystic and composer, but she also studied natural science and numbers. Her writings combined music, mathematics, and theology, which, let's be honest, is quite a combo. She would have been the ultimate interdisciplinary professor today. But if we want to talk about where math really flourished in the Middle Ages, we have to move east to the Islamic Golden Age. Cities like Baghdad, Cordoba, and Cairo became centers of learning. Scholars translated Greek works, invented new mathematics, and pushed the boundaries of algebra, geometry, and astronomy. And yes, women were there too. One example is Lubna of Cordoba, a scholar in 10th century Spain. She was a mathematician, a poet, and a librarian in the Great Library of Cordoba. People said she could calculate with the speed of lightning, which is probably the medieval version of saying she was a human calculator. She worked alongside male scholars, copying, studying, and expanding the works of earlier mathematicians, and her name survived, which means she must have been exceptional enough that even the history books, written mostly by men, couldn't ignore her. Another fascinating story comes from Baghdad. There, in the House of Wisdom, scholars from all over the world gathered to study. We don't know all the names of the women who were involved, but records suggest that some women worked as copyists, translators, and even teachers. Remember, in that culture, education was highly valued, and while opportunities were still limited for women, it wasn't completely closed. Some daughters of scholars got to learn advanced mathematics and even pass it on. And think about this for a moment. While Europe was still arguing about whether zero was suspicious and maybe evil, scholars in the Islamic world were inventing algebra, literally inventing it. The word algebra itself comes from the Arabic al-Jabr, from the title of a book by al-Khwarizmi. Without this work, modern mathematics wouldn't exist, and women were present in that world, contributing quietly, even if they weren't always credited. Let's have a little fun comparison. If doing math in a medieval monastery was like using the first version of Microsoft Excel with no tutorial, then working in the House of Wisdom was like being on the cutting edge of Silicon Valley. Imagine scholars debating quadratic equations the way people now argue about iPhone updates. And somewhere in the background, women were there, preserving texts, teaching students, and sometimes making discoveries of their own. Now, it's easy to think that these women were exceptions, just rare flashes of genius in a male-dominated world. But the truth is, they were part of a quiet, ongoing presence. Women in convents, women in royal courts, women in libraries. They weren't always famous, but they kept the spark alive, and that spark would later ignite in the Renaissance. But before we leave the Middle Ages, let's acknowledge something important. Even when women weren't allowed in universities, even when their names were erased from the record, math itself didn't care. Equations don't check your gender before they let you solve them. A theorem doesn't refuse to reveal itself because you wear a veil or a nun's habit. Numbers are stubbornly democratic, and that means wherever there was curiosity, women found a way to learn, to calculate, to teach. And honestly, I like to imagine the everyday side of this. We always think of math as high theory, but medieval math was also practical. Calculating taxes, trade, navigation. Picture a woman running a market stall, quickly working out exchange rates in her head, faster than the men around her. Was she recorded in history? No. But did she do math? Absolutely. Some of the greatest mathematical minds in history may have been anonymous women calculating quietly in marketplaces, in convents, or at royal courts. So the Middle Ages weren't as dark as people say, especially when you look at the Islamic world. There was light, and in that light, women left their fingerprints on mathematics. Sometimes faint, sometimes clear, but always there. And with that, we move forward into the Renaissance, a time of art, science, and of course drama. Because in the Renaissance, women began to step more boldly into the spotlight of mathematics. They weren't just copying texts or teaching in convents anymore. They were writing books, debating with scholars, and sometimes even daring to lecture in universities. And as you'll see, some of them were absolute rebels. So grab your Renaissance hat, maybe a fancy ruffled collar, and get ready. Because next we'll meet the women who shook up the 1500s and 1600s and showed the world that math was not just a man's game. The Renaissance. A time when Europe woke up from the long medieval nap, stretched its legs and said, let's rediscover science, art, and maybe invent opera while we're at it. Painters like Leonardo da Vinci sketched flying machines, Galileo pointed telescopes at the heavens, and mathematicians scribbled formulas that would shape the modern world. And in the middle of all this brilliance, there were women who refused to stay silent. They weren't supposed to be there. Universities were still very much boys' clubs, with lectures delivered by men in long robes who probably thought deodorant was optional. But some women fought their way into the world of math anyway, and not just as spectators, as authors, teachers, and full-blown intellectual rebels. One of the most famous was Maria Gaetana Agnesi. Born in Milan in 1718, she was basically a child prodigy. By the age of 11, she could speak 7 languages. 7. At 11, I could barely speak one without tripping over my own words. She was nicknamed the walking polyglot, which sounds impressive but also a little exhausting. But here's where it gets interesting. While most child prodigies burn out or get pushed into music recitals, Agnesi dove into mathematics. By her 20s, she wrote a massive book called Istituzioni Analitiche, a textbook on calculus and algebra so clear and well organized that mathematicians across Europe praised it. Even the Pope was impressed. And let's be honest, if you can make calculus sound holy, you've achieved something remarkable. Now the funniest part is the curve she's most associated with, the Witch of Agnesi. The name makes it sound like she was brewing potions on graph paper, but actually, it was just a mistranslation. The original Italian word versiera meant turning curve, but someone mixed it up with aversiera, which means witch, and so forever after, the poor woman's curve became known as the Witch of Agnesi. Talk about bad PR. Imagine spending years writing about beautiful math, only to be remembered as the lady with the witch curve. But here's what I love about Agnesi. She lived in a society that expected wealthy women to marry well and throw fancy parties. Instead, she locked herself away with her books and studied math. Later in life, she even turned away from fame and spent her time working with the poor. A rebel in her own way, choosing brains over balls and gowns. She wasn't alone, though. Another Renaissance rebel was Elena Cornaro Piscopia. Born in Venice in 1646, she holds the title of being the first woman ever to receive a PhD from a university, not in math exactly, but in philosophy. Though she was deeply skilled in math, theology, and languages, she was so brilliant that the University of Padua had to invent new rules to even let her defend her thesis. Picture the scene. A grand hall full of professors expecting a man, and in walks Elena, calmly reciting Latin philosophy better than all of them combined. She crushed it, earned her doctorate, and made history. But of course, after that, the university said, well, okay, that was nice, but let's not do that again for a while. Classic move. Then there's the story of Isotta Nogarola, another Italian scholar from the 1400s. She wasn't strictly a mathematician, but she worked in logic, which is basically the philosophical cousin of math. She wrote letters debating with male scholars, holding her own in arguments at a time when women were told to stay quiet. One critic even accused her of immorality just because she dared to write about intellectual topics. That's right, apparently logic was scandalous. Forget dancing on tables, just write a treatise on Aristotelian syllogisms, and suddenly you're the talk of the town. And across Europe, smaller stories flicker. Women in convents studying astronomy, aristocratic daughters trained in geometry so they could appear clever at dinner parties, and then secretly taking it further than their tutors ever expected. Some of their names are lost, but their work left ripples. Here's the thing about the Renaissance. It was supposed to be about rediscovery, about rebirth. But even in that so-called enlightened age, women still had to fight twice as hard to be heard. The men got statues, commissions, university chairs. The women got whispers, ridicule, or, if they were very lucky, a small note in a dusty chronicle. But the rebels refused to give up. Agnesy writing her giant math book, Piscopia earning her PhD, Noguerola debating logic. These weren't side characters. They were central to the story. They proved that math was not a male-only language. It was, and always will be, a human one. And here's where I want to pause and add a bit of humour. Imagine being one of their male colleagues, sitting in a study group, and realising the woman next to you just solved a problem faster than you. What do? Do you congratulate her? No. If you're a Renaissance man, you probably cough loudly, write down her answer in your notebook and pretend it was yours all along. Some traditions, sadly, are timeless. Still, the Renaissance rebels cracked the door open. They weren't always welcomed, but they couldn't be ignored either. They showed that brilliance will find a way, even if it has to sneak past the gatekeepers, and their courage paved the road for the women who came after, in the Enlightenment and beyond. So as the Renaissance gave way to the 1700s and 1800s, the stakes got even higher. Women would take on bigger challenges, from Fermat's last theorem to the birth of computer science. They would outsmart emperors, challenge academies, and sometimes even beat Napoleon at his own game. But we'll get to that soon. For now, let's raise a toast, preferably in a fancy Renaissance goblet, to the women who rebelled against their time, who wrote, taught, argued, and calculated when the world told them not to. They were rebels, yes, but more than that, they were pioneers. Every era has its rebels, and in the 1700s and early 1800s, one of the loudest mathematical rebels was Sophie Germain. If you've never heard of her, don't worry, that's because history didn't exactly roll out the red carpet for her. But Sophie was the kind of person who looked at barriers, shrugged, and said, okay, I'll just find a clever way around them. She was born in Paris in 1776, the year of the American Revolution. While America was busy declaring independence, Sophie was busy declaring independence from the idea that women couldn't do math. From a young age, she was fascinated by numbers. At 13, she found a book about Archimedes, the ancient Greek mathematician who was killed by a soldier despite strict orders to spare his life. That story lit a spark in her. She thought, if this guy could love math so much he didn't even notice a soldier coming at him, maybe math is worth my time too. So Sophie began teaching herself. But there was one problem. Her parents. They did not approve. They thought math was unsuitable for young girls. So at night when they thought she was sleeping, Sophie would sneak out books and study by candlelight. Her parents caught her once, shivering in the cold, wrapped in quilts, scribbling equations. Instead of being proud, they tried to stop her. They took away her candles, her clothes, anything she could use to study late at night. Did that stop Sophie? Of course not. She just found more candles and kept going, because nothing says future mathematician quite like a teenager arguing with their parents about staying up too late to do math homework. By her late teens, Sophie wanted more than books. She wanted real mathematical discussion. But universities in France didn't accept women. The École Polytechnique, the most prestigious school in Paris, was strictly male. So Sophie pulled off one of the greatest academic hacks of all time. She stole the lecture notes of a student and studied them on her own. Then she started sending in written responses and questions to professors under a fake male name. She called herself Monsieur Leblanc. And guess what? The professors bought it. They thought she was a quiet, brilliant young man. One of those professors was Joseph Louis Lagrange, one of the giants of mathematics. He was impressed with Monsieur Leblanc's work and asked to meet him. Imagine his surprise when a young woman walked into the room instead of a shy student in trousers. To his credit, Lagrange didn't flip the table. He accepted her and became one of the few mentors who encouraged her talent. But Sophie's biggest adventure came when she tackled Fermat's last theorem. This was the math problem that drove people insane for centuries. Fermat had scribbled in the margin of a book that he had a truly marvelous proof that the equation x nen plus y nen z nen has no integer solutions for n greater than 2. He never wrote down the proof, which is the mathematical equivalent of posting "I know the secret to life" on Twitter and then logging off forever. Mathematicians obsessed over this for 300 years. Sophie was one of them. She developed methods to prove the theorem for certain cases, using prime numbers in a clever way. While she didn't solve the whole problem, her work laid important groundwork. And remember, she was doing this in secret, often with limited resources, often being dismissed simply because she was a woman. Now let's talk about Napoleon. Yes, that Napoleon. Short guy, big hat, huge ego. In 1809, the Paris Academy of Sciences announced a prize competition to solve the problem of vibrations in elastic surfaces, basically how things like metal plates vibrate. It was a big deal, not just for math, but for engineering and physics. Napoleon himself sponsored it. Sophie decided to enter, again as Monsieur Leblanc. She worked tirelessly, developing mathematical formulas for elasticity. Her first 2 attempts didn't win, but she didn't give up. On her 3rd try, she nailed it. She became the first woman to win a prize from the Paris Academy of Sciences. Napoleon's name was attached to the competition, but Sophie was the one who cracked it. In other words, she outsmarted the emperor. Now, picture Napoleon, strutting around in his military uniform, thinking he's the smartest guy in the room. And somewhere in Paris, Sophie Germain is quietly winning his science competition. If that's not a satisfying image, I don't know what is. Her work on elasticity was groundbreaking. In fact, it became the foundation for modern engineering of structures, bridges, and buildings. Every time you walk across a suspension bridge or drive in a car designed with vibration theory, you are living in Sophie Germain's world, and yet for decades she barely got credit. Even when she won, some members of the Academy still muttered that it wasn't proper for a woman to do this kind of work. Sophie also corresponded with Carl Friedrich Gauss, one of the greatest mathematicians of all time. She wrote to him, again under the name Monsieur Leblanc, to discuss number theory. Gauss was impressed, writing that her ideas showed true genius. When he eventually learned her real identity, he was stunned, but instead of dismissing her, he praised her courage. He wrote, "How can I describe my admiration for such extraordinary genius, united with so much modesty? Coming from Gauss, that's basically the Nobel Prize of compliments." Unfortunately, Sophie lived in a time that never fully accepted her. She never held a university post, never got the recognition she deserved in her lifetime. She died at just 55, from breast cancer, largely uncelebrated by the academic world. It wasn't until later that her name was honoured. Today, one of the streets in Paris is named Rue Sophie Germain. There's also a school, Lycée Sophie Germain, and mathematicians talk about Sophie Germain primes, a special type of prime number she studied. But here's what I find most inspiring. She wasn't just brilliant, she was relentless. When society told her no, she found another way. Fake names, candlelight studies, stolen lecture notes, she used every trick in the book to keep going. And she proved that mathematics wasn't just a man's game. It was about curiosity, persistence, and a refusal to quit. So the next time someone tells you math is hard, remember Sophie Germain, a woman who against all odds outsmarted her parents, outwitted the universities, impressed Gauss, and even won Napoleon's prize. Not bad for someone who was never supposed to study math in the first place. And now, as we move forward into the 1800s, we'll meet more women who carried that rebellious torch, women who translated Newton, wrote best-selling science books, and even predicted the future of computers. So grab your powdered wigs and quills, because our next stop is with Mary Somerville, the woman who explained the universe so clearly that people started calling her the Queen of Science. If Sophie Germain was the quiet rebel who outsmarted Napoleon, then Mary Somerville was the great translator of the universe. Not a translator of languages, though she could do that too, but a translator of ideas. She had a gift for taking the most complicated, intimidating mathematics and turning it into something people could actually understand, which, let's be honest, is a skill the world still desperately needs. Mary was born in Scotland in 1780, into a respectable family, and like many women of her time, she wasn't expected to do much more than marry well, run a household, and maybe embroider some nice curtains. Her father, a naval officer, thought education for girls was a waste of time, but Mary had other plans. She was fascinated by puzzles, patterns, and the natural world. As a child, she once got in trouble for trying to teach herself algebra from the strange symbols in the back of a book. Her family thought she was wasting her time with masculine studies. Her mother even tried to cure her obsession with math by locking away her candles so she couldn't stay up late reading. Sound familiar? Sophie Germain would have nodded in solidarity. But Mary was relentless. She found tutors, she read everything she could get her hands on, and she taught herself advanced mathematics in secret. Eventually she married a doctor who, luckily for history, was supportive of her studies. Unlike many husbands of the time, he didn't tell her to stop. He encouraged her, which just goes to show behind every brilliant woman there's hopefully at least one man smart enough to get out of her way. Mary's big breakthrough came not from inventing a brand new theory, but from explaining existing ones so clearly that people finally understood them. Her book, The Mechanism of the Heavens, was a translation and explanation of Laplace's Mécanique Céleste, a dense mathematical text that described how the universe works. Laplace was a genius, but his writing style was, let's call it, less than user-friendly. Reading his book was like trying to decode alien messages while being smacked in the face with a chalkboard. Mary took those ideas and wrote them in a way normal humans could follow. When her book came out in 1831, it was a sensation. For the first time, educated readers across Europe could understand the mathematics behind the motion of planets and stars. Her explanations were so good that Cambridge University adopted her book as a standard text. Yes, a woman's writing became the textbook for one of the most prestigious universities in the world. That's how clear she was. She turned math into literature. But Mary didn't stop there. She went on to write several other works, including On the Connection of the Physical Sciences. That book was groundbreaking because it showed how different branches of science, astronomy, physics, chemistry were all linked by underlying mathematical laws. In fact, it was in the reviews of that book that the word scientist was first coined. Before that, people used terms like natural philosopher. So in a way, Mary Somerville didn't just explain science, she helped name the people who do it. And let's add some humor here. Imagine being so good at explaining things that your readers literally invent a new job title. That's like writing a cookbook so clear that people say, we need a new word for this person. Let's call them a chef. Mary became famous in her lifetime, which was unusual for a woman in science. She corresponded with leading mathematicians and physicists, including Laplace and Charles Babbage, the inventor of the early computer. She also supported Ada Lovelace, who we'll talk about in the next chapter. Together, Mary and Ada formed a sort of intellectual power duo, one translating the universe, the other predicting the future of computing. But what made Mary remarkable wasn't just her intellect, it was her humanity. She used her fame to advocate for education and for women's rights. She was one of the first people to sign John Stuart Mill's petition for women's suffrage in Britain, and in her later years, she still studied math daily, even as her eyesight began to fail. Picture an elderly Mary, squinting at equations by the window, still hungry to learn. That's dedication. Here's a fun anecdote. The mathematician William Well once said that Mary Somerville was the most extraordinary woman in Europe, and considering this was the same continent that had Beethoven, Napoleon, and a very large number of dramatic opera singers, that's saying something. Her legacy lives on not just in her books but in her name. Somerville College at Oxford University was named after her in 1879, and it was one of the very first women's colleges in Oxford. The symbolism is beautiful. A college dedicated to women, named after the woman who helped teach the universe to the world. But let's zoom out for a second. Why does Mary Somerville matter? Because she shows us that math isn't just about discovery, it's about communication. It's about taking a wild, complicated universe and putting it into words people can grasp. Without translators like Mary, the discoveries of Laplace or Newton might have stayed locked away, accessible only to a handful of geniuses. She opened the door so everyone could walk in. And she did it with style. She wasn't dry. She wasn't boring. Her books had elegance, clarity, even beauty. She made math readable, which, let's be honest, should earn her a Nobel Prize in patience if nothing else. So next time you open a science book that actually makes sense, tip your hat to Mary Somerville. She paved the way. She showed that explaining is as important as discovering, and she proved that women could be not just students of math but leaders, authors and shapers of how we understand the world. From secret studies in candlelight to best-selling books that defined an era, Mary Somerville turned herself into the voice of science. And while history sometimes forgets the rebels, it also remembers the translators. Her words, her clarity, and her vision live on. And speaking of vision, our next stop is with her friend and collaborator, Ada Lovelace. Mary explained the universe, but Ada looked forward and imagined machines that could calculate, compose music, maybe even tell bedtime stories like this one. So buckle up, because the next chapter is about a woman who basically dreamed up the computer before computers existed. If Mary Somerville was the translator of the universe, then Ada Lovelace was the dreamer of the future. She didn't just see math as numbers on a page. She saw it as a language that could one day make machines sing, paint, and even write. In a time when most people thought machines were just clunky things that made socks or pumped water, Ada imagined something more. She imagined computers. Ada was born in 1815, and her life was unusual from the start. Her father was the famous poet Lord Byron, known for his wild lifestyle and dramatic love affairs. He left Ada's mother when Ada was just a baby and disappeared from her life. Her mother, determined that Ada would not inherit Byron's poetic madness, decided to push her daughter into mathematics and science, because as every parent knows, nothing cures a creative streak like a good dose of algebra. Little did her mother know, that decision would change history. Ada fell in love with numbers. She had a brilliant, restless mind, and she combined her father's imagination with her mother's insistence on logic. The result was a mathematician who dreamed in equations but thought like a poet. By her late teens, Ada was introduced to Mary Somerville, the great translator of science we just met. Mary became her mentor and friend, and through Mary, Ada met Charles Babbage. Babbage was an eccentric genius, a man with wild hair and wilder ideas. He had designed a machine called the difference engine, basically a giant mechanical calculator made of gears and levers. It looked like a cross between a clock, a typewriter, and a steampunk nightmare. Babbage showed his invention to Ada, and she was fascinated. But while most people saw it as a fancy calculator, Ada saw something else. She saw potential. Babbage later designed an even more ambitious machine, the analytical engine. It was never built in his lifetime, but on paper it was a general-purpose computing machine. And Ada realized that it could do far more than just crunch numbers. Here's where Ada made history. She translated a paper about Babbage's analytical engine, originally written in French, but she didn't stop at translation. She added her own notes, longer than the paper itself, explaining what the machine could really do. In those notes, she described how the engine could be programmed with instructions, not just to calculate numbers, but to manipulate symbols in general. She even wrote an algorithm, step-by-step instructions for how the engine could calculate Bernoulli numbers. That algorithm is widely considered the first computer program in history. Let that sink in. 100 years before the first actual computers were built, Ada Lovelace wrote the first program. She saw what no one else did, that machines could follow instructions to do tasks beyond math, even to create art or music. She wrote that the engine might compose elaborate and scientific pieces of music of any degree of complexity or extent. In other words, she predicted computer-generated music. If Ada were alive today, she'd probably have a Spotify playlist called Beats by Babbage. Now, let's pause for a little humour. Imagine Ada trying to explain her ideas at a 19th century dinner party. Yes, my good sir, I believe this machine will one day be able to compose symphonies. And some guy in a powdered wig just laughs and says, "Machines making music? Preposterous." Meanwhile, 2 centuries later, his great-great-great-grandkids are listening to dubstep on laptops. Ada won that argument. But of course, like many women in our story, Ada's genius wasn't fully appreciated in her lifetime. She was dismissed by some as overly imaginative. Some critics even said she was delirious for thinking machines could ever do more than add and subtract. In truth, she was simply ahead of her time, so far ahead that it took the world a century to catch up. Ada's life wasn't easy. She struggled with health problems most of her adult life. She dabbled in horse racing and gambling, applying her math skills to predict winners. though not always successfully, and she died tragically young, at just 36 from cancer. But in her short life she planted a seed of an idea that would grow into the entire modern world of computing. Today she's rightly celebrated as the first computer programmer. The US Department of Defense even named a programming language after her, Ada, and every year the world celebrates Ada Lovelace Day, a reminder of women in STEM fields. But beyond the honours and the statues, what makes Ada special is her vision. She didn't just see math as dry calculation, she saw it as poetry. She imagined machines not as lifeless things but as partners in creativity. She connected logic with imagination in a way no one else had dared to do. And that's the lesson of Ada Lovelace. Mathematics isn't just about what is, it's about what could be. It's about imagination. And sometimes the wildest dreamers are the ones who change the world the most. So next time you open your laptop, send a text or stream a video, remember Ada. Long before Silicon Valley, long before Wi-Fi and smartphones, there was a young woman with a poetic father, a determined mother, and a mind that saw the future in the turning of gears. From candlelit notes in Victorian England to the glowing screens of today, her vision lives on. She was forgotten for a time, dismissed as fanciful, but she was right. Machines can follow programs, machines can create, and it all began with Ada Lovelace, the first computer programmer. And speaking of pioneers, Ada wasn't alone in the 19th century. There were others, mathematicians who wrote brilliant papers, solved deep problems, and sometimes got a little lost in the footnotes of history. Next, we'll shine a light on them. From Sophie of Alexandria to unsung heroines across Europe, these women carried the torch forward. So let's turn the page and meet the other 19th century pioneers of mathematics. So far we've met Sophie Germain, who tricked Napoleon, and Ada Lovelace, who dreamed up computers. But the 19th century was full of other women in mathematics, some famous, some nearly forgotten, who carried the torch forward. They weren't always celebrated in their lifetimes. Some had to fight just to attend class, some had to publish under men's names, and some, despite producing brilliant work, died in obscurity. But together, they form a constellation of pioneers, bright stars scattered across a dark sky of prejudice. Let's start with Sophia Kovalevskaya. Born in Russia in 1850, she grew up surrounded by numbers. In fact, her nursery walls were literally covered in mathematical notes. Her father had run out of wallpaper and instead used old lecture notes from calculus. So baby Sophia grew up staring at integrals and differential equations before she could even read. That's one way to get a head start. Imagine learning to walk while staring at the chain rule. From an early age, Sophia wanted to study seriously, but Russian universities didn't allow women. So what did she do? She invented what historians politely call a fictitious marriage. She married a man not for love, but so she could leave the country and study abroad. Basically, she hacked the marriage system. Oh, you want me to marry? Fine, but I'm marrying my way to math class. Respect. With her fake husband's cooperation, she moved to Germany and studied at Heidelberg and then Berlin. But even in Berlin, she wasn't allowed to formally enroll, so she attended lectures in secret or had professors give her private lessons. Eventually, she earned a doctorate from the University of Göttingen in 1874, becoming the first woman in modern Europe to receive a PhD in mathematics. Her dissertation was on partial differential equations, one of the hardest areas of math. She didn't just pass, she crushed it. Sophia went on to become a professor in Sweden. At Stockholm University, she was the first woman in Europe to hold such a position. She published important work on analysis and mechanics, and her name still appears in theorems today. But her life was also tragic. She struggled for recognition, for financial stability, and for acceptance. She died young, at 41, from pneumonia. Still, her story remains one of defiance and brilliance. She proved that women could not only study math at the highest levels, but also push the field forward. Now let's move to England, where another pioneer, Charlotte Scott, was breaking barriers. Born in 1858, she became one of the first women to study at Cambridge. She sat for the famous mathematical tripos exam in 1880. This exam was so difficult it was basically a math marathon. People trained for years, and the top scorers were celebrated like celebrities. Charlotte sat for the exam, and she did brilliantly. But there was a catch. Women weren't officially recognised. So when they announced the results, they read out the men's names. And then, almost as an afterthought, someone stood up and said, "Oh, and by the way, Miss Charlotte Scott did very well too." The audience of students gave her a huge cheer, because even they knew the system was ridiculous. Charlotte later moved to the United States, where she became a professor at Bryn Mawr College, one of the first colleges for women. She mentored a generation of young female mathematicians, proving that education is contagious. Her impact wasn't just in her papers, but in the lives of her students. And speaking of professors, another name worth remembering is Grace Chisholm Young. She studied in the late 1800s when women were still excluded from most universities. She earned her doctorate in Göttingen, just like Sophia Kovalevskaya, and became a prolific mathematician. But here's the sad twist. Many of her papers were published under her husband's name. Historians now believe she wrote the majority of their joint work. It's like she was ghostwriting entire math theorems. Imagine being so brilliant that your husband becomes famous just by signing your papers. Across Europe, other names flicker. Fanny Edgeworth in Ireland, Philippa Fawcett in England, and countless others who tutored, translated, and wrote quietly in the margins of history. Philippa, by the way, deserves a shout-out. In 1890, she sat for the Cambridge Tripos exam and actually scored higher than the top male student. Higher. She was the best mathematician in Cambridge that year. But because women weren't officially ranked, she was listed only as above the senior wrangler, which is a very British way of saying, she won, but let's not talk about it too loudly. And then there's Ellen Hayes in America, a professor at Wellesley College, who was outspoken not only in mathematics but also in politics and women's rights. She once famously said that the exclusion of women from higher education was a crime against humanity. Bold words for the 19th century. The pattern is clear. Again and again, women proved themselves. Again and again, they were told, "Nice work, but we're not going to officially recognize it." And again, they kept going anyway. Here's where I want to pause for some humor. Imagine all the times a woman outscored the men in exams or produced better research, and the professors had to awkwardly shuffle their papers and say, well, let's just call that an exception. At some point after the 10th or 100th exception, maybe you realize it's not the women who are unusual, it's the rules that are broken. The 19th century was a turning point. Women like Kovalevskaya, Scott, Young, and Fawcett didn't just sneak into math. They kicked down the door. They showed that talent knows no gender, and they inspired the next generation of women who would enter the 20th century ready to fight for full recognition. So while some of their names are less famous today, their contributions built the bridge between the rebels of the Renaissance and the modern pioneers of the 20th century. Without them, there would be no Emmy Noether, no Katherine Johnson, no Karen Uhlenbeck. They kept the flame alive. So let's remember them not as footnotes, but as trailblazers. Women who solved equations, wrote theorems, taught students, and proved the world wrong one calculation at a time. And now, as we step into the 20th century, the story gets even bigger. Because here we meet Emmy Noether, the woman Einstein himself called a genius. She wasn't just a mathematician, she rewrote the rules of physics and math itself. And true to form, history almost forgot her. But not tonight. Tonight she takes the spotlight. If there's one name that absolutely deserves to be shouted from the rooftops of mathematical history, it's Emmy Noether. She's the kind of mathematician whose work was so powerful that Einstein himself stopped what he was doing and said, wow. And yet, most people today have never even heard of her. Which is wild, because if you've ever enjoyed modern physics, things like relativity, conservation laws, or even the idea that symmetry rules the universe, you owe a thank you to Emmy. Let's rewind to 1882. Amalie Emmy Noether was born in Erlangen, Germany. Her father was a professor of mathematics, so numbers were in the family, but Emmy wasn't supposed to follow in his footsteps. As a girl, she was expected to learn music, sewing, and dancing. She did none of that with much enthusiasm. Instead, she fell in love with puzzles and problems. By her teens, she wanted to study mathematics seriously, but German universities didn't exactly welcome women. At first, she had to sit in on classes unofficially. Imagine sneaking into a math lecture like it was a rock concert. Eventually, though, she was allowed to enroll, and she quickly outshined her peers. She completed a doctorate in mathematics in 1907. Her dissertation wasn't flashy. It was about invariance in algebra, but it showed the seeds of the brilliance that would later bloom. Here's where the story gets unfair. Even with a PhD, Emmy wasn't given a proper job. Women couldn't hold faculty positions in German universities at the time, so for years she lectured for free. Free. Professors used her ideas, her methods, her teaching, and she wasn't paid a cent. Sometimes her lectures were even advertised under male professors' names, as if she were some invisible ghost of genius. Imagine going to class, learning from Emmy, and the sign outside says, "Professor Schmidt's lecture." Brutal. But Emmy kept going. She had something bigger than recognition. She had ideas that burned inside her brain, ideas too important to ignore. And in 1915, she wrote down something that changed physics forever. This is Noether's theorem. Now don't panic, I'm not going to throw equations at you. I'm going to tell you what it means in plain words. Noether's theorem says that every symmetry in nature corresponds to a conservation law. Sounds fancy, but here's an example. The laws of physics don't care where you are in space, whether you're in Paris, New York, or floating somewhere near Jupiter. The basic rules are the same. That symmetry, space being uniform, implies the conservation of momentum. Likewise, the laws of physics don't care when you run your experiment. Do it today, do it tomorrow. The rules are the same. That symmetry, time being uniform, implies the conservation of energy. In other words, Emmy showed that the deepest laws of the universe, energy, momentum, angular momentum, are not random. They come from symmetry. It was like pulling back the curtain and revealing the hidden architecture of reality. Einstein himself, working on general relativity at the time, was stunned. He later wrote that Emmy's work was a monument of mathematical thought, and when Einstein calls your theorem a monument, you know you've done something right. But here's the twist. Even after this revolutionary insight, Emmy still didn't get the respect she deserved. For years, she worked under temporary or unpaid positions. It wasn't until 1922, 15 years after her doctorate, that she finally received the title of associate professor, and even then her salary was modest, far below her male colleagues. The injustice is staggering. Yet in her classroom she was legendary. Emmy was known for being warm, enthusiastic, and a little chaotic. She often showed up in crumpled clothes, hair a mess, scribbling equations furiously on the board. Students adored her because she taught not just math but passion. She believed that mathematics wasn't about memorizing formulas, but about exploring ideas. She would say, "Look at the structure, look at the beauty, look at the pattern." Her lectures were less like rigid lessons and more like joyful explorations. Her students went on to become some of the great mathematicians of the 20th century. They called themselves Noether's boys, and here's a fun irony. Even though the academic system undervalued her, she ended up shaping the very people who carried mathematics into the modern age. That's legacy. But then came the rise of the Nazis in Germany. Emmy, being Jewish and politically progressive, was forced out of her position in 1933. She fled to the United States and took a post at Bryn Mawr College, a women's college in Pennsylvania. There, for the first time, she found an environment that truly welcomed her. She taught young women mathematics with the same enthusiasm she had always shown. She even gave lectures at Princeton, though Princeton itself still didn't allow women students. Tragically, Emmy's time in the US was short. In 1935, just 2 years after arriving, she died suddenly from complications after surgery. She was only 53. Einstein wrote her obituary, praising her as one of the greatest mathematical geniuses of all time. But even then, her name didn't become as famous as his, or as Newton's, or as Gauss's. She was remembered in specialist circles, but not by the public. And yet, Noether's theorem is everywhere. Every time a physicist talks about conservation of energy, they're quoting Emmy. Every time we marvel at the symmetry of the cosmos, we're standing on her shoulders. Her work is as fundamental as Einstein's relativity or Newton's laws. She changed the way we understand reality itself. So why isn't she a household name? Partly because she was a woman in a man's world. Partly because she worked in abstract mathematics, which doesn't lend itself to simple stories like apples falling on heads. But mostly because history just didn't bother to put her in the spotlight. And that's why we're here, to tell her story, to remember. Because Emmy Noether wasn't just the Einstein of math. Honestly, that label sells her short. She was Emmy Noether, a genius in her own right. A woman who looked at the universe, saw its hidden symmetries, and wrote them down for us all. And so, as we leave Emmy's story, we step into another dramatic chapter of the 20th century. A time when math wasn't just about discovery, but survival. when wars raged and mathematicians were recruited not for classrooms but for code breaking. And in that world too, women played a crucial role. Our next stop is World War II, where women in secret rooms cracked the codes that helped win the war. If Emmy Noether gave us the math that explained the universe, then the women of World War II gave us the math that saved it. Because when the world went to war, numbers weren't just abstract symbols anymore, they became weapons. Equations, ciphers, and algorithms decided battles just as much as tanks and planes. And some of the most important codebreakers of the war were women. Let's start in Britain, in a place called Bletchley Park. From the outside, it looked like a big country estate, complete with gardens and a manor house. But inside, it was the beating heart of British code breaking. Here, some of the brightest minds in the country gathered to crack the German Enigma machine. Enigma was a cipher device used by the Nazis to send secret military messages. It was so complex that the Germans believed it unbreakable. Every day they changed the settings, creating billions of possible combinations. To most people, that was an impossible puzzle. To the women of Bletchley, it was Tuesday. Among these women was Joan Clark. She was a brilliant mathematician who had studied at Cambridge. But when she graduated, she wasn't awarded a full degree, because Cambridge didn't give degrees to women at the time. They literally said, "Congratulations, you've done all the work, but we don't think you deserve the paper." That's like finishing a marathon and being told, "Sorry, no medal, but here's a nice pat on the back." Still, Joan didn't let that stop her. At Bletchley Park, she worked alongside Alan Turing and others on breaking Enigma. She developed methods to reduce the number of possible Enigma settings, which was crucial for the Allied code breakers. Her brainpower helped shorten the war and save millions of lives. And yet, for decades, almost nobody knew her name. Now, let's hop across the Atlantic to the United States. There, another incredible woman, Elizabeth Smith Friedman, was cracking codes before most people even knew code breaking was a thing. She and her husband, William Friedman, are often called the first true cryptographers of the modern era. Together they laid the foundations of American code breaking. During World War II, Elizabeth led a team that intercepted and solved Nazi spy messages sent from South America. She broke codes that revealed entire espionage networks. She didn't have advanced computers. She didn't even have Bletchley's massive machines. She used pencil, paper, and raw intellect. Her work was so sensitive that for years after the war, the government kept it classified. Other people got the credit. Elizabeth's role stayed in the shadows. And it wasn't just Britain and America. Women everywhere were pulled into code breaking. Thousands worked long hours in secret facilities, poring over intercepted messages, trying to spot patterns. It wasn't glamorous, it was exhausting, repetitive, and mentally draining. Imagine staring at endless streams of letters, hoping to notice that the enemy used the same word twice. Yet these women kept at it, day after day, because they knew every cracked message could save lives. And here's the thing, breaking codes isn't like in the movies. It's not all dramatic aha moments where someone suddenly yells, "Got it!" Most of the time it's slow, methodical work, trying possibilities, crossing them out, starting again. It's basically Sudoku on steroids, except the prize isn't bragging rights, it's stopping a U-boat from sinking a convoy. But let's sprinkle in some humor, because you know me by now. Imagine explaining this job at a family dinner in 1943. So what do you do all day? Oh, I stare at random letters for 14 hours, drink tea, and occasionally save civilization. Not exactly a job description you can fit on a resume. What's even more amazing is that most of these women couldn't even tell anyone what they were doing. It was top secret. They had to keep silent, sometimes for the rest of their lives. After the war, many of them went back to ordinary jobs, raising families, never speaking of the role they played in defeating the Nazis. It's like the world's greatest unsung choir, singing in perfect harmony, then vanishing into silence. And here's the bigger point. These women proved once again that mathematics isn't just about dusty blackboards and abstract theorems. It's about life and death. It's about decoding reality itself. Whether it was Emmy Noether uncovering the laws of physics or Joan Clark cracking Enigma, math has always been about more than numbers. It's about survival. Let's not forget that their work also laid the foundation for modern computing. The code-breaking machines at Bletchley Park, like the Bombay and Colossus, were early precursors to digital computers, and women were at the center of their operation. They weren't just solving the problems, they were literally running the machines that became the ancestors of your laptop and smartphone. So the next time you send a text, play a video game, or watch cat videos on the internet, you can thank the women of World War II. They helped create the digital age, even if history tried to keep them hidden. Of course, recognition has been slow. For decades, their stories remained classified or ignored. Only recently have books and movies begun to tell their tales. Films like The Imitation Game finally put Joan Clark on the map, though even then she was more of a side character to Alan Turing's story. But now we can say her name, and Elizabeth Friedman's and all the others, they deserve to stand in the spotlight. So let's raise a toast to the secret mathematicians of the war, the women who bent over ciphers, cracked impossible codes, and quietly tipped the balance of history. Without them, the war might have dragged on for years. Without them, the modern world of computers and communication might never have come to be. And with that, we move from the war rooms to the space race, because the next chapter belongs to another group of brilliant women, human computers at NASA, who calculated trajectories, launched rockets, and sent astronauts to the moon. Their story was hidden too, until recently, but now it shines as one of the greatest chapters in math history. If World War II was the proving ground for women codebreakers, then the space race was their launchpad into history, because while astronauts got the glory of walking on the moon, it was women armed with pencils, paper, and slide rules who calculated the paths that made it possible. They were called human computers, and without them, NASA's rockets might have ended up in the ocean, or worse, stuck on the launch pad. Let's start with Katherine Johnson. Born in 1918 in West Virginia, she was a math prodigy from the start. By the age of 10, she was already in high school. By 18, she was in college. While most of us at that age were still struggling to figure out how to do laundry, Katherine was mastering analytic geometry. She joined NASA, then called NACA, in 1953. At first, she worked in a segregated computing pool, a group of black women mathematicians who did calculations by hand for engineers, segregated bathrooms, segregated offices, but the same equations as everyone else. Katherine quickly stood out. She had a way of understanding orbital mechanics so naturally that engineers began pulling her into meetings where women, especially black women, were not usually welcome. She calculated flight trajectories, re-entry paths, and emergency backup plans. When John Glenn prepared to become the first American to orbit the Earth, he didn't trust the new electronic computers alone. He famously said, "Get the girl to check the numbers." The girl was Katherine Johnson. She ran the numbers by hand, confirmed the machine's calculations, and Glenn said he'd fly only if she approved. Think about that. The fate of America's space program rested on her pencil and paper. Then there was Dorothy Vaughan. She joined NACA in 1943 and became the first black supervisor at NASA. She led the West Area Computing Unit and made sure her team thrived. But Dorothy wasn't just a manager. She was a visionary. When electronic computers began to arrive at NASA, many feared losing their jobs. Dorothy saw the future. She taught herself the programming language Fortran and trained her entire team. They transformed themselves from human calculators into some of NASA's first computer programmers. That foresight kept them essential, and it made Dorothy a quiet hero of the digital age. And let's not forget Mary Jackson. She started as a human computer too, but her engineers pushed her to study more. She fought through the segregated education system, petitioning to attend classes at an all-white high school so she could qualify as an engineer. She became NASA's first black female engineer. Her work focused on aerodynamics, how air flows over rockets and spacecraft. Without her insights, the sleek ships of NASA might not have flown so smoothly. Together, Katherine, Dorothy, Mary, and countless others kept America's space dreams alive. They weren't just solving equations. They were solving the problem of getting fragile humans safely into the harsh vacuum of space, and then bringing them back without turning them into meteorites. Every line of math was a line of hope. And here's the part that blows my mind. They did it all with pencils, paper, and slide rules. No laptops, no calculators, no fancy software, just raw intellect. Picture a room full of women quietly scribbling rows of numbers, double-checking every digit. Because one mistake could send a rocket spinning into disaster. The pressure must have been intense. But they did it, again and again. Of course, for decades their contributions went unnoticed by the public. Astronauts were household names. Engineers got recognition. But the women in the computing pools, They were hidden. Their work was considered support, not center stage. That changed only recently, thanks to the book and film Hidden Figures, which finally brought their stories into the light. Millions of people who had never heard of Katherine Johnson or Dorothy Vaughan suddenly knew their names, and they deserved every bit of that recognition. Let's add a little humor here. Imagine you're an astronaut about to launch on a rocket the size of a skyscraper. Someone tells you, "Don't worry, a computer checked all the math." And you say, "That's great." Then they add, "Actually, a woman with a pencil checked the math too." Suddenly you're a lot calmer, right? Because computers can glitch. But Katherine Johnson with her pencil, that's trustworthy. Beyond the math, these women were also pioneers in breaking down barriers of race and gender. They worked in a segregated America, often denied opportunities, recognition, even basic respect. And yet they kept showing up, they kept calculating, they kept proving that talent knows no boundaries. And let's not forget, NASA's success wasn't just about getting to the moon. It was about building confidence in science, in math, in technology. The work of these human computers paved the way for satellites, GPS, telecommunications, even the smartphone you might be holding right now. Their calculations echo in every piece of modern technology. So the next time you look up at the moon, remember this. The path to get there wasn't carved just by rockets and engines. It was charted by women with pencils, working quietly in rooms that history nearly forgot. Katherine Johnson lived long enough to see her work celebrated. In 2015, at age 97, she received the Presidential Medal of Freedom. Dorothy Vaughan and Mary Jackson were also honored posthumously. NASA even named a building after Katherine. A fitting tribute, though. Honestly, they could have named the entire space program after her, and it still wouldn't capture her impact. But for me, the most powerful tribute is this. When those women sat down at their desks, they weren't just calculating orbits. They were proving every day that intelligence belongs to everyone, that math is not male, not female, it's universal, and that sometimes the greatest heroes of history are the ones who don't seek the spotlight at all. So as we leave NASA's human computers, we carry with us their quiet courage. The courage to show up, to solve the impossible, to do the math, even when the world tells you you don't belong. And with that, we move forward into the later 20th century, where more women broke barriers in mathematics, not just in hidden roles but at the forefront of research. From Mary Cartwright to Julia Robinson, from logic to chaos theory, they carried the legacy into new territory. And one of them would even go on to win the Fields Medal, the Nobel Prize of Mathematics. But that's a story for our next chapter. By the time the mid-20th century rolled around, women in mathematics had already shown they could crack codes, launch rockets, and rewrite the laws of physics. But the story didn't stop there. In the modern era, women kept pushing the boundaries of what math could do. And slowly, very slowly, the world began to give them the recognition they deserved. Let's start with Mary Cartwright. Born in 1900 in England, she was one of the first mathematicians to dive into what we now call chaos theory. You've probably heard of the butterfly effect, the idea that a butterfly flapping its wings in Brazil might set off a tornado in Texas. Well, Cartwright was one of the pioneers who studied the strange, unpredictable behavior of dynamical systems. She worked on equations that at first seemed like simple problems about radio waves, but the solutions turned out to be messy, unpredictable, and, well, chaotic. Her work with J. Littlewood laid the foundation for modern chaos theory. This wasn't just abstract fun, it had applications in physics, engineering, even weather forecasting. Imagine being Mary Cartwright in the 1930s, scribbling down equations that didn't behave nicely, and realizing you'd just peeked into one of the deepest truths of nature, that order and chaos are two sides of the same mathematical coin. And she wasn't just brilliant in her research. She was also the first woman to serve as president of the London Mathematical Society. Think about that. An organisation that had existed for over a century before, finally saying, okay, maybe a woman can lead us? Progress sometimes crawls like a snail, but eventually it moves. Next, let's talk about Julia Robinson. If Sophie Germain was the rebel who outsmarted Napoleon, Julia was the quiet fighter who tackled one of the hardest problems in math, Hilbert's 10th problem. Back in 1900, the great mathematician David Hilbert posed 23 problems for the 20th century to solve. They were like a mathematical to-do list for humanity. Number 10 was about Diophantine equations. Could there be an algorithm to determine whether any given polynomial equation has an integer solution? It sounds technical, but basically Hilbert was asking, can we teach math to solve its own puzzles automatically? Julia Robinson dedicated her life to this problem. For decades she chipped away at it, publishing important results that brought the world closer to an answer. She collaborated with other mathematicians around the globe, pushing the problem further each time. Finally, in 1970, the solution came, not from Julia alone, but from a young Russian mathematician named Yuri Matyasevich. Using Julia's earlier work as a foundation, he proved that the answer was no, there is no general algorithm. Some math problems simply can't be automated. Julia didn't solve Hilbert's 10th in the way people imagine, but without her, Matyasevich wouldn't have been able to finish the puzzle. She laid the groundwork, piece by piece, with patience and brilliance, and her name is forever linked to one of the great sagas of 20th century math. But Julia's story is also one of resilience. She battled illness throughout her life, often working while sick, never letting go of her mathematical drive. She became the first woman president of the American Mathematical Society in 1983, breaking yet another barrier. Then, in the 21st century, the spotlight finally shone on another trailblazer, Karen Uhlenbeck. In 2019, she became the first woman to win the Fields Medal, the most prestigious award in mathematics, often called the Nobel Prize of Math. The Fields Medal had existed since 1936, 83 years, and not a single woman had ever won it. And then came Uhlenbeck. Karen's work was in geometric analysis and gauge theory fields so advanced that even most mathematicians scratched their heads trying to follow. But what made her stand out wasn't just the depth of her research, it was the way she shaped entire areas of modern mathematics. Her insights influenced theoretical physics, especially in understanding the math behind quantum field theory and string theory. She showed once again that the line between math and physics is blurrier than people think. And Karen wasn't shy about speaking the truth. She often pointed out how difficult it was for women in math, how lonely it could feel to be the only one in the room. When she won the Fields Medal, she said she hoped her victory would show young women that they belong in mathematics, that the path is tough but possible. So from Cartwright to Robinson to Uhlenbeck, the modern era gave us women who didn't just participate in math, they led it. They weren't assistants or footnotes or side characters. They were presidents of societies, builders of theories, winners of the highest prizes. But let's sprinkle in some humour, because math stories can get heavy. Imagine if Hilbert could see the result of his 10th problem. He'd probably sigh and say, wait, so the answer is no? You mean I gave you a problem that's literally impossible? My bad. Meanwhile, Julia Robinson is standing there politely saying, yes, Professor Hilbert, but it took us 70 years to prove it. Or picture Mary Cartwright explaining chaos theory at a dinner party in the 1940s. Someone asks, so what do you study? And she says, well, I study systems so sensitive that a small change could create a completely different outcome. And the person replies, oh, like my marriage, to which she'd probably nod politely and say, yes, exactly. The point is, these modern trailblazers proved that women didn't just belong in mathematics, they excelled at the very top. They cracked problems no one else could crack. They guided institutions. They paved the way for today's generation of mathematicians, where women are increasingly visible, increasingly recognized, though the journey is still far from finished. So as we close this chapter, let's remember them not just as mathematicians, but as leaders, pioneers, and visionaries. Mary Cartwright saw order in chaos. Julia Robinson wrestled with the limits of algorithms. Karen Uhlenbeck stood at the pinnacle of mathematics, medal in hand, showing the world that barriers can be broken. And as we move into the final section of our journey, we'll step back and ask the big questions. Why were these women forgotten in the first place? How did their math change the world anyway? And what does it mean to be first, to break into a world that tells you you don't belong? Those reflections are coming next, as we piece together the bigger picture of this long hidden history. So by now we've met a whole galaxy of women: Hypatia, Germain, Lovelace, Noether, Johnson, and so many more. Each of them brilliant, each of them groundbreaking. And yet most of them were forgotten for decades, even centuries. Which begs the question, why? Why did their names fade while men's names got carved into marble statues and stamped onto theorems? The simple answer is sexism. But let's go a little deeper, because history isn't just one villain twirling his mustache. It's layers upon layers of bias, culture, and, let's be honest, some very insecure men. First, there's the issue of access. For most of history, women weren't allowed into the places where math happened. Universities, academies, societies, locked doors everywhere. Imagine trying to play chess, but you're only allowed to watch from outside the window. That's what women faced. Even when they studied on their own, like Sophie Germain or Sophia Kovalevskaya, their work was dismissed as hobby math, as if theorems written in the kitchen somehow count less than theorems written in a lecture hall. Then there's the problem of credit. Over and over we see the same story. A woman contributes, publishes, or even solves something huge, and the credit goes to a man nearby. Grace Chisholm Young wrote papers that got published under her husband's name. Lise Meitner co-discovered nuclear fission, but Otto Hahn got the Nobel Prize. It's like history was playing a cruel game of credit card theft, stealing their names while keeping their work. And let's not forget stereotypes. For centuries, people believed women simply weren't capable of abstract thought. Doctors published actual scientific studies claiming math would damage a woman's health. One even argued it would make their womb shrivel up. Yes, apparently solving equations was considered a threat to reproduction. If that were true, math professors today would be an endangered species. There was also the cultural narrative. People love stories of lone geniuses. Newton under the apple tree, Einstein with his chalkboard. Those stories are dramatic, simple, easy to teach. The reality that math is collaborative, messy, and built by teams of people, including women, doesn't fit the myth. So history edited the women out to make the story cleaner. And of course there's plain old power. Men controlled the institutions. They decided who got jobs, who got published, who got remembered. And let's face it, many of them didn't want to share the spotlight. Better to pretend the women weren't there than admit they were just as smart or smarter. Now let's pause for a little humour, because this is heavy. Imagine a 19th century university professor getting a letter from Sophie Germain under her fake male name. He's impressed. He praises Monsieur Leblanc. Then he finds out it's actually a woman. Suddenly he's like, maybe I misjudged. It's the academic equivalent of catfishing, but with calculus. Or picture a codebreaker in World War II, a young woman who cracks an impossible cipher. She hands her solution to her male superior, who announces the breakthrough as if he did it himself. That's basically group projects in school, just on a world-saving scale. But here's the twist. Despite all the erasure, the math survived. Theorems don't care who proved them. Symmetries don't vanish because the wrong name is attached. Bridges still stand. Rockets still fly. Codes still crack. The ideas outlived the prejudice. Which means that when we dig into history, we can rediscover the women who were always there, waiting in the margins. And honestly, the rediscovery is one of the best parts, because it makes the story richer. Instead of just a line of bearded men, we get a full, diverse cast of characters. Rebels like Germain, dreamers like Lovelace, teachers like Somerville, fighters like Kovalevskaya. Each of them adds texture to the history of math. So why were they forgotten? Because society wasn't ready to tell their stories. But here's the good news, we are. Books, films, and even YouTube channels, are finally putting their names back where they belong. History isn't set in stone. It's more like a chalkboard you can always erase and rewrite. And maybe that's the ultimate lesson. The problem isn't that women weren't in math. The problem is that history had selective memory. Like a badly edited highlight reel, it showed us Newton's apple, but not Noether's theorem. It showed us Pythagoras' triangle, but not Theano's golden ratio. It showed us astronauts planting flags, but not Katherine Johnson plotting the path to get them there. So as we look back, we shouldn't just feel frustration, we should feel excitement, because we get to rediscover these hidden figures and tell their stories in full. And once you know their names, you can't unknow them. They're part of the fabric now. To wrap this up, let's imagine math history as a giant tapestry. For centuries, the weavers left out half the threads. The picture looked incomplete, skewed, and strangely monochrome. Now, as we put the missing threads back, the pattern comes alive. It's brighter, fuller, more beautiful. And in the next chapter, we'll see just how much these forgotten women actually changed the world anyway. Spoiler alert, without them, we wouldn't have bridges, rockets, or maybe even computers. So if you thought their contributions were just footnotes, get ready to see how they reshaped reality itself. We've talked about how women were forgotten, pushed aside, erased. But here's the kicker. Even though history tried to silence them, their math still changed the world. Because the universe doesn't play favorites. If the equation works, it works. Doesn't matter if it's proven by a man in a powdered wig or a woman scribbling by candlelight. The math survives, and the impact is everywhere. Let's start way back with Hypatia. She taught conic sections, ellipses, parabolas, hyperbolas. 2,000 years later, NASA used those exact curves to calculate spacecraft orbits. Every time a rocket loops around a planet to slingshot further into space, that's Hypatia's math at work. So the next time you watch a Mars rover land, remember, somewhere in the background is a woman in ancient Alexandria, sketching conic sections on papyrus. Fast forward to Sophie Germain. Her work on elasticity theory laid the foundation for modern engineering. Bridges, skyscrapers, even airplanes rely on equations she helped develop. Next time you drive across a suspension bridge, think of Sophie. Without her math, you might be taking a very long swim. Mary Somerville's books did something equally powerful. By explaining Laplace's complicated theories in plain language, she made them accessible. That translation helped spread Newtonian and Laplacian physics across Europe. In other words, she didn't just do math, she made sure the world understood it. And understanding is the first step to invention. Then we have Ada Lovelace. She never touched a laptop, never saw a microchip, but her vision of a programmable machine laid the philosophical groundwork for the entire computer revolution. Every algorithm, every line of code, every smartphone app traces back to her insight. Machines could manipulate symbols, not just numbers. Ada didn't just predict computers, she predicted the digital age. And let's not forget Sophie Germain. Her work on partial differential equations was crucial in physics and engineering. PDEs describe how things change. Heat spreading through metal, waves rippling through water, air flowing over a wing. Entire industries run on PDEs. Without Kovalevskia's contributions, modern science would be flying blind. Literally, planes wouldn't fly the same without her math. Jump ahead to Emmy Noether. Her theorem tied symmetries to conservation laws. That single insight became the backbone of modern physics. Without Noether, Einstein's relativity wouldn't fully make sense. Quantum mechanics wouldn't fit together. Our entire picture of the universe, why energy is conserved, why momentum is conserved, rests on her shoulders. Noether's work didn't just change math, it changed reality. Then there are the codebreakers, Joan Clark at Bletchley, Elizabeth Friedman in America. Their math cracked ciphers that altered the course of World War II. Every intercepted message meant lives saved. Without them, the war could have dragged on for years. The world we live in today might look very different if it even existed at all. That's not just math, that's survival math. And the human computers at NASA, they took humanity to the moon. Katherine Johnson's trajectory calculations, Dorothy Vaughan's programming, Mary Jackson's engineering, they all shaped the space race. The Apollo missions weren't just rocket fuel and bravery, they were equations. And many of those equations came from women who had to fight for a seat at the table. Modern trailblazers carried the torch even further. Mary Cartwright's chaos theory explains why weather forecasts are so tricky, why markets behave unpredictably, why nature dances between order and disorder. Julia Robinson's work on Hilbert's tenth revealed the limits of algorithms, knowledge that's crucial in the age of artificial intelligence. Karen Uhlenbeck's contributions shaped the mathematics behind quantum fields and modern physics. These aren't just abstract ideas, they're the foundations of technology, medicine and science in our everyday lives. Here's the irony. The world forgot their names, but it never stopped using their math. That bridge you cross, that phone in your pocket, that spacecraft orbiting Mars, it's all running on equations built, explained or imagined by women whose stories were erased. History may have ignored them, but reality couldn't. And here's a fun way to think about it. Imagine the universe as a giant operating system. Women in math were writing the hidden code, patching bugs, adding features. History's textbooks were like user manuals that left their names out. But the system still runs on their work. Every time the sun rises and conservation of energy holds true, Emmy Noether gets the last laugh. Let's sprinkle in a little humour too, because these stories deserve some smiles. Picture Ada Lovelace transported to 2025, staring at a TikTok algorithm. She'd probably say, "Yes, I predicted machines making music. I did not predict people dancing with cats for likes." Or imagine Sophie Germain walking across a modern bridge. She'd glance at the steel cables and mutter, "You're welcome," before striding off. The point is, these women weren't side characters. They were main characters all along. Their math shaped the modern world in ways so deep we barely notice anymore. It's in the physics that govern the cosmos, the technology in your hand, the structures that hold up your city, the codes that protect your data. So when we ask, how did their math change the world? The answer is simple. It built the world. Even if their names weren't carved into monuments, their equations are carved into reality. And now, as we move into the next chapter, we'll look at the human side of it all, because changing the world wasn't easy. Being the first came with tragedy as well as triumph. What did it mean to fight alone, to sacrifice, to carry the weight of being the only one? That's the story we'll tell next, the price and the glory of being first. Being first always sounds glamorous. First on the moon, first to climb Everest, first in line at the bakery when they bring out fresh croissants. But when it comes to women in mathematics, being first often came with as much tragedy as triumph. It meant carrying the weight of expectations, criticism, and isolation. It meant walking into rooms where nobody wanted you, and proving yourself over and over again. Take Hypatia. She was the first woman in recorded history celebrated as a mathematician. But her reward wasn't statues or medals, it was persecution. She became a target for political and religious violence, murdered brutally by a mob. Her death wasn't just personal tragedy, it was symbolic, a warning shot to anyone who dared to question authority with reason. Hypatia's story shows us the risk of being first. The brighter you shine, the more you attract those who want to snuff you out. Or Sophie Germain. She fought to study math when French universities barred women. She wrote letters under a fake male name, smuggling her ideas into academia. Her triumph? Lagrange and Gauss praised her brilliance. Her tragedy? She never held a professorship, never got the recognition she deserved in her lifetime. Imagine working twice as hard, proving yourself 3 times over, and still being treated as a curiosity rather than a colleague. That's the lonely side of being first. Sophia Kovalevskaya knew that loneliness too. She invented a fake marriage just to study abroad. Her triumph? She became the first woman professor of mathematics in modern Europe. Her tragedy? Constant struggle for acceptance, financial instability, and an early death at just 41. She carried the title of first, but the cost was high. Even Ada Lovelace, celebrated today as the first computer programmer, lived a life of contradictions. Her triumph? Seeing what no one else could see, that machines could do more than calculate. Her tragedy? Dismissed as fanciful, mocked for her imagination, dead at 36 before the world could understand how right she was. Being first meant writing the prologue but never getting to see the story unfold. And then there's Emmy Noether. The triumph? Writing a theorem so fundamental that modern physics collapses without it. The tragedy? Lecturing for free for years because universities wouldn't pay a woman. Even after Einstein praised her as a genius, she remained on the margins. Her life is proof that being first doesn't mean being celebrated. It often means being overlooked until decades later. The same story repeats in the 20th century. Katherine Johnson, Dorothy Vaughan, Mary Jackson, NASA's human computers. Their triumph? Sending astronauts to space, calculating paths to the moon. Their tragedy? Doing it in segregated offices, fighting for basic recognition. Imagine doing the math that gets humanity to the moon and still having to walk to a coloured bathroom. Triumph and tragedy, hand in hand. And here's the deeper truth. Being first often meant being alone. These women had no role models who looked like them, no established path to follow. They were pioneers in a wilderness of prejudice. Every step forward was carved with resistance. It wasn't just math they had to solve, it was society. But here's the flip side. That very loneliness, that very struggle, made their triumphs even greater. Hypatia's voice still echoes 2,000 years later. Sophie Germain's elasticity theory still holds up bridges. Ada Lovelace's vision powers every computer we touch. Emmy Noether's theorem still underpins the universe. Katherine Johnson's trajectory still arcs across the sky. Their tragedies were real, but so were their triumphs, and the triumphs endure. Let's add a little humour here, because otherwise this chapter gets heavy. Picture Sophie Germain sneaking her math under a fake name. It's like the original version of making a fake profile online. Instead of catfishing, she was math-fishing. Or think of Katherine Johnson double-checking NASA's computers by hand. Today, if your calculator says 2 plus 2 5, you throw it away. Back then, NASA basically said, if the computer says one thing and Katherine says another, we go with Katherine. That's power. The tragedy of being first is the resistance. The triumph is the persistence. These women didn't just survive, they changed the landscape for those who came after. Each of them cracked the door open a little wider, so the next generation could step through. Hypatia inspired legends, Germain inspired Gauss, Somerville mentored Lovelace. Johnson's story inspired millions once it was told. Each first was a lonely beacon, but together they lit a path. And maybe that's the ultimate takeaway. Being first is hard, often heartbreaking, but without the first, there can never be the second, or the 100th. Without Emmy Noether, would physics have recognized symmetry's role so quickly? Without Ada Lovelace, would we have seen computers as more than calculators? Without Katherine Johnson, would John Glenn have trusted his rocket? Each of them bore the weight of being first, and in doing so they made it easier for others to follow. So yes, there is tragedy in their stories. Early deaths, unrecognized work, endless barriers, but the triumph is louder. Their math survived, their ideas lived on, and today their names are finally rising from the footnotes to the headlines. So the next time you hear someone say she was the first woman to, remember the double edge of that phrase. It's a crown, but also a burden, a triumph, but also a tragedy. And it's a reminder that while being first is lonely, it's never in vain, because once the path is broken, others can walk it too. And now, as we head into the next chapter, we'll look at what happened after the forgetting. Because here's the good news, these women are no longer invisible. Their stories are being told in books, films, and classrooms. They're being remembered, not as tragedies, but as triumphs. And that, perhaps, is the most important victory of all. For centuries, the women we've been talking about were pushed into the margins of history. Their names erased, their work credited to others, their stories told only in whispers. But here's the good news, they're not forgotten anymore. In the last few decades, something amazing has happened. Historians, writers, filmmakers, and scientists have started shining a spotlight on these women, bringing them out of the shadows and into the headlines. Take Katherine Johnson, Dorothy Vaughan, and Mary Jackson. For decades, their work at NASA was little more than a footnote in technical reports. Then came Hidden Figures, first the book, then the movie. Suddenly, millions of people around the world knew their names. Katherine Johnson went from being the girl who checked the math to a national icon, standing beside presidents honored with the Presidential Medal of Freedom. Dorothy Vaughan and Mary Jackson were celebrated for their brilliance and leadership. Their legacy wasn't hidden anymore. It was front and center. The same thing happened with Ada Lovelace. For a long time, she was remembered only as Lord Byron's daughter. Her notes on Babbage's analytical engine were dismissed as fanciful musings. But now, she's celebrated as the world's first computer programmer. There's a programming language named after her. There's an Ada Lovelace Day every year celebrating women in STEM. Imagine telling her back in the 1840s that one day she'd have an international holiday in her honor. She probably would have raised an eyebrow and said, finally. Emmy Noether too has finally gotten her due. For decades, physicists whispered her name, but the general public never knew it. Now she's recognized as one of the most important mathematicians in history. Entire conferences are dedicated to her. Universities name buildings after her. Physicists call her theorem one of the most beautiful insights ever written. Einstein praised her during her lifetime, but now the world is catching up. And then there's Sophie Germain. For most of her life, she was dismissed as eccentric. Her contributions to Fermat's last theorem nearly forgotten. But today there are mathematical prizes named after her, schools that bear her name, and her work is recognized as crucial in number theory and elasticity. It took 2 centuries, but she's finally being celebrated as the genius she was. Even women like Hypatia, whose story is shrouded in legend, are being reclaimed. Historians now write entire books about her, not just about her tragic death, but about her teaching, her brilliance, and her courage. She's become a symbol of knowledge against ignorance, reason against fanaticism. Statues of Hypatia stand in universities. Her name is invoked as a patron saint of mathematics. She's not forgotten anymore, she's immortalized. And it's not just the famous names. Historians are digging up the stories of women who are truly buried by history, the librarians, the translators, the assistants who are much more than assistants. Scholars are rereading old papers, realizing that the anonymous or supporting authors were often women. We're piecing the puzzle back together, and it's revealing a picture richer than anyone imagined. Here's a little humor break, because you know I can't resist. Imagine Sophie Germain or Emmy Noether walking into a modern math conference. They'd probably laugh and say, "Wait, you're all quoting me? And you finally spelled my name right? About time." Or picture Katherine Johnson being told there's a Hollywood movie about her life. She'd likely smile, nod, and say, "Well, I did warn them the computers couldn't be trusted without me." But the point is this: forgotten no more. These women are finally being recognized, taught in classrooms, celebrated in movies, honored with awards. Their stories inspire not just mathematicians, but anyone who's ever felt overlooked, because their lives remind us that brilliance doesn't disappear. It can be ignored, yes, but it waits. And eventually someone picks up the trail and says, "Who was this person? What did she do?" And the answer changes everything. And here's the beautiful part. The rediscovery of these women doesn't just rewrite history, it reshapes the future. Every young girl who hears Ada Lovelace's story might think, "I could write code too." Every student who learns about Katherine Johnson might think, "I could be an engineer." Every time Emmy Noether's theorem is taught, a new generation of physicists is reminded that genius comes in many forms. Recognition matters, not because these women need our applause, they're gone and their math speaks for itself. Recognition matters because it tells today's students you belong here. It tells the world, mathematics is not just the story of a few famous men, it's the story of humanity. So, yes, they were forgotten, but no, not anymore. Their names are coming back, louder than ever. And maybe that's the ultimate triumph. Because while history can erase names, it can't erase truth forever. Sooner or later, the equations, the proofs, the stories, they all come back. And as we move into the next chapter, we'll take a step back from the history books and look at the beauty of mathematics itself, not just through the eyes of Newton or Einstein, but through the women who lived it, loved it, and taught it. Because math isn't just formulas, it's a way of seeing the universe. And sometimes the people who are forgotten see it most clearly of all. We've spent this whole journey telling stories of forgotten women, rebels, dreamers, codebreakers, teachers. But let's pause now and ask, how did they see mathematics? What was the beauty of math through their eyes? Because while men often told the story of math as conquest, Newton conquering the universe, Gauss conquering numbers, many of these women saw math differently. For them it wasn't just about winning or proving, it was about connection, creativity, and wonder. Take Hypatia. For her, mathematics was philosophy. She didn't separate numbers from life. To her, geometry wasn't just about lines and circles. It was about harmony, about understanding the structure of reality. She taught in Alexandria not because she wanted glory, but because she believed math could elevate the soul. Imagine a classroom where math wasn't a punishment, but a path to wisdom. That's the beauty she saw. Sophie Germain, locked away with her candlelight, saw math as persistence. Every equation she solved was an act of rebellion. To her, beauty wasn't just in the neatness of a proof. It was in the courage to keep going when everyone said no. The elegance was in the fight, in the stubbornness of a woman scribbling equations against the rules of her society. Ada Lovelace? She saw math as poetry. Literally, she wrote that numbers could represent more than quantity. They could represent patterns, relationships, even music. To her, math wasn't just calculation, it was imagination. Where others saw gears and levers, Ada saw a machine composing symphonies. Her beauty was in possibility, in dreaming of futures that didn't exist yet. Mary Somerville found beauty in translation. She believed the universe spoke in the language of mathematics, but it was too difficult for most people to understand. So she became the interpreter, turning dense equations into stories people could follow. For her, beauty wasn't just in the math itself, but in sharing it, in lighting up someone else's understanding. Emmy Noether. She saw beauty in structure. She didn't just want to solve equations. She wanted to understand the deep patterns that held everything together. Her theorem connecting symmetry to conservation is often described as one of the most beautiful ideas in physics. To Emmy, beauty was the elegance of unity, seeing that the laws of the universe weren't scattered accidents, but a single woven fabric. Katherine Johnson saw beauty and precision. For her, every digit mattered, because lives were on the line. But she also saw beauty in the sheer possibility. Her equations sending rockets into space, her numbers reaching all the way to the moon. Imagine the joy of seeing a spacecraft arc across the sky, and knowing your math put it there. That's beauty in motion. Dorothy Vaughan and Mary Jackson found beauty in adaptation, in learning new tools, mastering new languages like Fortran, breaking barriers and proving that math could evolve just as they did. For them, the beauty was in resilience, the idea that no matter how the world changed, numbers would always be there waiting to be understood. And the modern trailblazers, Mary Cartwright with chaos, Julia Robinson with algorithms, Karen Uhlenbeck with geometric analysis, they all found beauty in complexity. They looked at problems that seemed messy, unsolvable, infinite, and found hidden order. For them, beauty wasn't about simplicity. It was about embracing the wildness of math and still finding patterns. Here's the thing. Through their eyes, math wasn't cold or mechanical. It was alive, it was creative, it was human. For too long, people told the story of math as a battlefield of geniuses, each one trying to outdo the last. But these women remind us math can also be a garden. Something you nurture, something that grows, something that connects us. Let's sprinkle in some humour here, because math deserves a smile. Imagine Ada Lovelace meeting Katherine Johnson. Ada says, "I dreamed a machine that could calculate orbits." Katherine replies, "That's cute, I actually did it." Or Hypatia chatting with Emmy Noether. "I taught geometry to elevate the soul." Emmy answers, "I connected symmetry to conservation laws." Hypatia pauses and says, "Okay, you win." But jokes aside, the common thread is clear. They saw math not just as answers, but as meaning. Not just as problems, but as possibilities. And that's the beauty they left behind. And maybe that's the greatest gift of rediscovering their stories. It's not just about giving credit where it's due, though that matters. It's about seeing math differently, seeing it not as a cold tower of theorems, but as a tapestry woven by many hands, seeing it not as conquest, but as creativity, not as exclusion, but as belonging. Because when you look through their eyes, math is not a boys' club. It's not a secret society. It's a universal language that belongs to everyone. And the more voices that speak it, the richer it becomes. So the next time you look at an equation, or a pattern, or even the rhythm of waves on a beach, remember, this is beauty seen through many eyes. Through Hypatia's, Ada's, Emmy's, Catherine's, and countless others, each one added a new colour, a new thread, a new way of seeing, forgotten for a while, yes, but forgotten no more. And now, as we near the end of our journey, it's time to close the story with a gentle goodnight, to reflect on everything we've learnt, laugh one more time, and remind ourselves that even in the quietest hours, math has a way of keeping us company. And here we are. We've travelled from ancient Alexandria with Hypatia, through candlelit studies with Sophie Germain, into Ada Lovelace's dreams of machines, across bridges built with Sofia Kovalevskaya's equations, through the symmetries of Emmy Noether, into the secret code-breaking rooms of World War II, and all the way to NASA's launch pads and modern Fields Medal ceremonies. Quite the journey. If you're still awake right now, congratulations. You've just made it through a 2-hour bedtime story about forgotten math geniuses. That's either impressive or proof you've had way too much coffee today. But this is the moment where I want to slow down, breathe, and say goodnight. Because this wasn't just a list of biographies. It was a story about persistence, resilience, and the quiet power of mathematics. A story about people who weren't supposed to be here, but showed up anyway. A story about how history sometimes loses track of its heroes, only for us to find them again. Think about Hypatia, teaching geometry not as numbers on a page, but as a way of touching truth. Think about Sophie Germain, defying her parents, defying society, sneaking equations into letters under a fake name. Think about Ada Lovelace, staring at a pile of gears and imagining a machine that could compose music. Think about Emmy Noether, messy hair and chalk-covered clothes, discovering that symmetry is the heartbeat of the universe. Think about Katherine Johnson with her pencil, calculating the path to the moon. All of them, in their own way, saw beauty in math. And even when history tried to forget them, the beauty lived on. And here's what I love most. None of them asked for fame. None of them set out to become legends. They just followed curiosity. They just loved math. And that love, quiet, stubborn, sometimes dangerous, changed the world. So what's the lesson for us? It's simple. Math is not about who gets credit. It's not about names carved in stone. It's about connection. It's about patterns that tie us together across time and space. The same equations that Hypatia drew in sand guided Katherine Johnson's rockets. The same symmetries Emmy Noether wrote on a blackboard. Keep your lights on and your phone charged. The math is timeless. The names may fade, but the work endures. And that's comforting, isn't it? Because it means none of us are really forgotten. If we add even a tiny piece to the puzzle of understanding, it stays. Maybe our names won't be in textbooks. Maybe we won't have holidays or movies. But the work we do, the curiosity we nurture, the questions we ask, they ripple forward. They become part of the story. Let's add a little humour before we drift off. Imagine all these women sitting together at a cosmic dinner party. Hypatia raises a glass of wine. Sophie Germain mutters about how she had to use a fake name to get in. Ada Lovelace pulls out a laptop from the future just to show off. Emmy Noether rolls her eyes and explains why symmetry makes the wine glass possible in the first place. Katherine Johnson leans over and says, "By the way, I've already calculated the shortest path home," and they all laugh, because in the end, they know they've won. Their math survived, their story survived, and here we are, still telling them. So maybe the real goodnight message is this. Don't let history decide who matters. Tell the stories yourself. Share the names that deserve to be remembered. And remember that curiosity, imagination, and persistence are more powerful than any barrier. Now, if you've been listening to this while trying to fall asleep, this is the part where I say, it's okay to let go. Let the numbers float in your head like stars. Let the names drift by like constellations. Hypatia, Germain, Lovelace, Noether, Johnson. Their voices have carried us through centuries, and tonight they've carried you toward dreams. So close your eyes, rest, and know that even in the quiet, math hums in the background, steady, gentle, eternal. Equations whisper like lullabies. Symmetry cradles the universe. And forgotten no more, the women of mathematics watch over it all. Good night from the sleepless mathematician. If you're still awake, well, maybe one more story tomorrow. But for now, sleep well. You've earned it.